Hello and welcome back to the Aimless Electron. In the last episode I presented my idea for a reflow oven and some of the design requirements, and I tore down that Frigidaire toaster oven and took a look at the power supply board to see what we could reuse. In this episode I'll go into the design of the user control board, what components are needed, and maybe some of the board layout. And it'll be all from scratch. I only have some ideas. I haven't done any work ahead of time on this. I did take a look again at the front bezel of the toaster oven and I had an idea. In this toaster oven, there's a couple holes here for the buttons, and I thought maybe I'll add another button to do a toggle for the backlight on that screen. But this will probably end up being the select button and then some up-down buttons right here. And I'll probably reuse the plastic buttons that came with this and just relabel them. I also figured I'll tear this out and make it the emergency stop button. So let's get on to that design and see what we need. Alright, this should be a pretty simple design, though there are quite a few components on it. We'll start off with the XMega microcontroller itself, the 128, and let's draw some of the components we know we're going to need. I know that we are probably going to use one of the cold junction compensation ICs from Maxim, and I believe that's the Max 31855 CJC, the cold junction compensation. We know we're going to have that screen, the Nokia, well, made famous by Nokia anyways. I know we'll have USB, and I'm going to include also, just because it takes up pins, the ISP, the in-system programming port that will be used to actually program the XMega on board. Yeah, let's start with that. So I'll draw how these are connected together. This one is just the data plus and data minus. This one has a whole bunch of ports. It's got a full SPI port, a port for the reset, and then also it connects to ground and VCC. In other words, 3.3 volts. Oh, yes. This cold junction compensation chip also connects via SPI, and it has a chip select line. And the screen connects via SPI as well and has a data command line. Let me label these real quick. And we have CLK down here, data again, and this time command. On the screen we also have two other lines that we need to take into account, and that is the reset line, which is tied high, and this is just like, I don't know, we can use a 10k ohm for that, and then the chip select, which is, or chip enable, which is tied low. So just to be clear on that, this is reset and chip enable. That's a little better. Not much, but a little bit. Anyways, so that's the three main chips that we need. This has a backlight that I'd like to control as well, and for control on that, well, if you take a look at the little board here, it's got some LEDs connected directly to a pin, and there's a jumper that goes across here for these. So all those are connected to this pin. That happens to be the VCC pin. On the back, for the light itself, they're connected through to those LEDs via these, I think they're 300k resistors. There's 3000 written on them. So that'll look like this. And we'll start off with the lights themselves. And these, like I said, I believe they're 300 ohm. We can turn all of these on at once. I'm probably going to use 5 volts. I checked it and they work both at 3.3 and 5 volts just fine. It's just 5 volts is brighter. Anyways, we have just PNP, or NPN transistor controlling it with a little bit of current protection or current limiting and bias ground. This is going to be a 4.7k ohm, and same with this. Real quick, we also, I'll get to the outputs right away. We have only 3 outputs that we're going to use. We do have 4 total outputs that we could use right here. We have the motor control, the heater for the top, the heater for the bottom, and then the fan. The thing is, I'm only going to control the motor and the top and bottom heaters. The fan itself, I'm just going to turn on all the time. Now, it's kind of interesting. You look at this and you're like, well, why do we have a control for it? And I'll explain that in a minute and why we're doing it differently. So simple enough on that. Now we're going to go and talk about the buttons that we're going to use for the user interface. We're just going to tie them all to the 3.3 volt rail, and they're all just momentary switches that I'm going to connect via a resistor. The point of the resistor in this case is I'm going to use the internal pull-down resistor that you can configure on the input pins in the XMega, and I don't want a lot of current going through that, so I'm going to limit it here as well. And since it's CMOS, it only requires voltage, it doesn't really care about current, and that'll turn it on. I'll label these right away too, just so we know what we're looking at. I'm going to have a button for up on the menu and down on the menu, select, and then one for the backlight toggle, and these are all the backlight LEDs. Finally, I'm going to have one more switch. It's just going to control the power completely. So we'll have the AC live coming in, and it'll just go to a single pole, single throw switch, and then back out. And when this is open, it'll cut all power to everything. That's why we can have the fan always on. In this circuit, the power was always on and always powering the digital electronics, so we had to have a control to turn that fan off. In this case, since we'll have it controlled by a switch, and I think it's just going to be one of those lever switches, so we don't have to worry about a rocker switch or a push button. If something happens, you just flip that and everything shuts off. A couple other components I need to draw here. I also want a buzzer, right? So we're going to do the same kind of transistorized circuit that we had before, where this will probably tie to 5 volts as well. We'll have our buzzer and then a transistor, just another NPN, current limiting, and bias. And this again, we'll just use, since we're already using them, we'll just use another set of 4.7k ohms here. The last thing I want to add to this is the voltage regulator and some of the capacitors for cleaning up the voltage next to the chips. So we have the 3.3 voltage regulator and incoming 5 volt rail and outgoing 3.3 volt rail in our ground. So this is pretty standard. What I am going to do is add another electrolytic here, probably around a 22 microfarad or whatever I have lying around, and I'm thinking like a 10 microfarad over here. The only other part of the circuit that's needed for this cold junction compensator is the smoothing cap on the voltage on the power in, and I'll probably just use 0.0 or 0.1 microfarad ceramic caps like here, and probably here as well for the XMega. So, and I think there's usually about 3 that this requires, or 4 depending on if you're using the ADC. And that's all that's really needed for that. Oh, I almost forgot to put on the inputs for this. We have the actual temperature sensor, negative and positive, coming in. I don't think there's anything more to this circuit. This is pretty much it. So we have our in-system programmer, our USB connection to the outside world. This will just probably be a header on the board somewhere. Our cold junction compensator, our screen, our microcontroller, our buttons, our buzzer, backlight control, our outputs to control the oven itself, the voltage regulator, and I'll actually build this circuit board up on a breadboard probably in the next episode. I'm waiting for this this chip to come in. I haven't got it yet, but as soon as that comes in, I'll make this up. Okay, let's talk real quick about the software, and that'll probably be all that we do for this episode. So there's a couple modes that I want the software to run in, and that's what I want to go over first. I know there's at least 3 off the top of my head. There might end up being more, but for right now, let's go with this. We want a mode for run, which is actually the temp control, heating, stuff like that of the oven itself. We want a menu mode, where the user can select the profile that they want to run, and then maybe a startup mode. That startup mode will probably just display a little splash screen. The different things that the software has to do is next. It has to do USB to serial, because we have to actually implement that stack in software, but at least the hardware is there to support it. We have to decode AT commands, and that's what will be coming over from the serial, and that'll be able to individually control things like the different elements in, the heating elements, the motor, uploading the profiles. So we have to be able to read and write flash, because that's where we're going to store those profiles at, and also where we're going to read them from when we're looking for the names of the ones that we want to run. It's going to have to do graphics, and that's going to be things like drawing text and lines. And by the way, the graphics, since the screen is only 504 bytes, I plan to have it double buffered, so you're drawing to one buffer, one array of 504 bytes, and then when you give it a flush command or a draw command, it starts sending that over SPI to the screen, and you can be drawing to the second buffer, and those will just swap out. We need oven control. And oven control will be things like controlling the different heaters and controlling maybe the convection oven or convection fan. We need temperature monitoring. So that we can pull in the temperature. And there's one other thing that's kind of overarching on this, but before I get to that, button debouncing. The reason I mentioned those two things at the same time, or the one I haven't actually mentioned yet, timer. It also is going to have a timer in it. The timer is going to probably run at millisecond or sub-millisecond levels, or at least it's going to tick off an interrupt at millisecond or sub-millisecond levels. So we can use it to do the button debouncing, and we can use it to do timed temperature recordings and drawing on the screen, like say once every 1/10 of a second or something like that. And it will also be used to spit out a log file over serial if requested at a certain interval as well. So the timer is very important. And the timer is the only other thing that I'll actually be using the interrupts. The first one will be when we get a receive from the serial. When we get a receive from the serial, it's going to have to take those bytes and store them in its own little array or its own little buffer and decode the AT commands that way. And it may then have to write to flash or whatnot. Really, that's the full list of what the software has to do. The next thing I'd probably go over is, or probably try to decide, is what the AT commands are and how they interact. I was giving it some thought in my think tank, which is basically the shower. If anybody else uses that, you know what I mean. And it occurred to me that there's probably two situations in which you can use a command. One will be in a certain mode, like say when it's running, and one will be when it's not running. But we need to be able to control things like the temperature, or take the temperature, or get logging, turn things on and off like the backlight, and then also, very importantly, we're going to have to be able to upload and manage the profiles. So with all that said, there's a lot that's going to go into the software, and I'm going to probably take a look at those pieces individually, which I'll get in a later episode. The next thing I'm probably going to do is breadboard a few of the individual hardware pieces, like the screen, or taking the temperature control, or the USB connection and receiving AT commands. So stick around for that and we'll check that out. So I hope you enjoyed this episode. I'm trying to keep these a little bit shorter, and I'll probably have a few more of them before actually done with the oven. Also, I'd like to keep the design pretty fluid, so if I do make some changes to what I decided to do in the first place, I'll make sure I let you know. One of those things is, on the oven itself, I was going to originally place the kill switch as just a slap switch, and then I changed it to one of these lever switches, where I finally got in. And it fits in these holes almost perfectly, so I figure if I put some kind of mounting plate in there, I just use that. But I'm going to probably put it down here so I can cut the power completely, but the power isn't going to run very close or around the circuit board itself. And I might turn this hole into, say, a power on LED. So look for that in the upcoming design. Anyways, thanks again for watching. If you liked the video, give it a thumbs up, subscribe to the channel, leave me some comments, any suggestions or any criticisms or anything that you think I should do differently or you want to see me do. I appreciate it. And stick around for the next video. I'll see you soon.